All right, everyone. We're going to be transitioning here to Erika from Microsoft. She will be presenting on using Visual Studio with WSL to build and debug Linux applications from Windows.
My name's Erika. I work on Microsoft's Visual C++ team, specifically on the C++ cross-platform development team. And today I'm going to be chatting with you guys about C++ cross-platform development with Visual Studio and WSL. That's my Twitter handle and the team's Twitter handle below. So throughout the presentation or after, if you have questions, comments, feedback, anything that wasn't covered, you can just shoot us a tweet and use those Twitter handles, and we'll get back to you. So I'm going to start by quickly introducing and defining what we mean when we say our native support for WSL in Visual Studio. I'm also going to introduce our CMake support in Visual Studio, which is going to be a part of the demo. And then since we only have 30 minutes together, the bulk of my time is going to be spent in a demo. And at the end, I'm going to quickly go over our WSL2 story. So since Visual Studio 2017, we've had support for building and debugging C++ applications on a remote system over SSH. In Visual Studio 2019, we added native support for WSL. So basically, instead of invoking commands as if WSL were a remote system over SSH, all commands are executed locally. And what that means for you is that you can just have one single copy of your source tree. There's no need for Visual Studio to manage file copying or to keep two synchronous copies of your build tree, one on Windows and one on your remote system. This leads to no dependency on SSH at all, so it's quicker, easier to get started, and also leads to performance improvements. If you're using Visual Studio 2019 version 16.4 or later, then you can leverage the new integrated terminal to interact directly with WSL in Visual Studio, which will also be part of my demo today. CMake, if you are not using it, is a cross-platform open source meta build system. It's really popular among C++ developers, specifically those who are doing C++ cross-platform development. We see from surveys administered by GitHub or by ISO-CPP. And it is our recommendation for anything cross-platform or with an eye to open sourcing. So CMake support in Visual Studio means that you can open any folder containing a cmakelist.txt file, interact with the project, build it, debug it locally on Windows, on WSL, or on a remote system without ever generating Visual Studio project and solution files. You can still leverage the full suite of IntelliSense code navigation debugging features that you might be used to with like a normal Windows project, as well as some CMake specific features like project editing support, language services for CMake scripts to help you make sense of, edit, and author your own CMake scripts, which is also going to be something that I'm talking about today. So with that, I'm just going to dive right on into a demo. Here I have a CMake project open in Visual Studio. It looks and behaves very similarly to like normal projects and solutions with a few key differences. The biggest one being we have the concept of the CMake settings editor. So this is where I can go to tell Visual Studio where CMake is going to be invoked, whether that's locally on Windows, on a remote system, or on WSL. I can specify things like configuration type, my compilers, environment variables, and for WSL, you can also specify which WSL executable should be used with Visual Studio in case you have different distros installed side by side. So right now, I'm building on WSL with the GCC toolset. This editor that you see is just an overlay on top of a CMake settings.json file that you can check into source control as a part of your repo so that all this configuration specific to your project only needs to be done once. The project that I have open is just a cross-platform command line calculator that takes in a series of postfix expressions and then evaluates them. So I'll just run it, show you how it works. Note that when I'm debugging, since I'm debugging directly on WSL, we're using the front end of the Visual Studio debugger backed entirely by GDB. So you can see right away, I am prompted with the Linux console window, which is a way for you to interact with your applications that are running on WSL directly. So it reads in input, so I can read an expression, x equals 2, read in another expression, just x, and then I can evaluate the second expression, or in this case, x plus x. And it looks like I have run into an address sanitizer exception. So address sanitizer is a runtime memory error detector for C and C++ that used to be native to Linux and Mac, and we've integrated it directly with the Linux workload in Visual Studio, so you can see ASAN errors in the context of Visual Studio when you're debugging on WSL. I say used to because we actually very recently ported it over to Windows to be used with the MSVC toolset as well. But yeah, we should be native to Linux and Mac. So it looks like I am getting a heap buffer overflow error, so I'm going to try to figure out what's going on. So I'll go over to the call stack, step through, and so it looks like here I have an array indexed at 0 with 2 elements, but I'm trying to access the second element, which is out of bounds. So I'm going to see where this M expression number is being set. So I will find all references. It looks like all these bottom results are just comparison operations. This is where it's being set in this file. So I'll go here, and yeah, it looks like I'm reading in all of the expressions, but then setting the expression number equal to the red number, which to have a better user experience, this should probably be red number minus 1, so that if the user wants to evaluate their second expression, they were accessing the first element of the array. So I'll make those changes, save the file. I'm going to go back to the call stack and set a breakpoint where this M expression number is actually being evaluated. I'm just setting a normal breakpoint, but when you're debugging on WSL, you have the full suite of debugging features available to you. So you can set conditional breakpoints that will break only if a certain condition is met. You can set trace points that will continue code execution. It's basically like a bunch of printf statements without you actually having to modify your code. I don't actually want either of these, but when you're debugging backed by GDB, you have the full suite of debugging features available to you. So with that set, I will stop execution and restart. Wait for it a little bit. All right, so I'm back to my Linux console window. I'll read in the same expressions as last time. So x equal 2, read in x plus x, evaluate the second expression, hit my breakpoint. This time, this array hopefully still has 2 elements, but I'm trying to access the first element. That looks much better. If I continue execution, I can see that is evaluated to 4, which is correct. Last debugging feature that I want to show you guys today, I'll go ahead and pause the debugger, but you can actually interact with the underlying debugger, in this case GDB, directly. So if I go over to the command window and I use the command debug.mi debug exec, MI engine is the open source engine that we use to communicate with GDB, then I can execute any GDB command that I want. So let's say that I want to view an assembler dump of this get command function. Then I can view the full assembler dump right in the context of Visual Studio. And it's pretty long, but there it is. So Hopefully this shows you that when you're debugging on WSL with Visual Studio, you can both leverage the full fidelity Visual Studio debugging experience that you might be used to, so a visual experience for navigating the call stack or setting breakpoints or examining variables, but we're also trying to bring native Linux tooling into Visual Studio, so things like address sanitizer or the ability to execute your custom GDB commands and just in a way that might be easier to interact with GDB instead of using the command line. So far I've been debugging, but now I want to add a logging library in case anyone else who's using this code base runs into errors and wants to send them over. So I'll go over to my CMake list.txt, which is where I declare all my dependencies on third-party libraries, and I'm going to use the find package command. You can see that I'm getting IntelliSense suggestions and tooltips, which is a part of the in-editor CMake documentation that we added, which renders official CMake documentation directly in the IDE. So I'm going to add glog, which is just a logging library, and I'll add big required. Save the file. And it looks like Visual Studio is yelling at me because I don't actually have the glog package installed on WSL. But I'm getting this quick fix here to install glog using VC package on WSL. So I'll select that and then kind of talk to you about what's happening here. So if you haven't heard of it, VC package is a C++ package manager well, for C and C++ libraries that allows you to bring down, build, and install C and C++ libraries from source on Windows, Linux, and Mac from the command line. So here you can see that it's installing the x64 Linux triplet of the glog library directly on WSL, and it's routing all of the output back to the output window in Visual Studio so that I can keep an eye on it. I got this quick fix suggestion because I already had VC package installed on WSL. So at the end of my deck, I have some the documentation on how to install VC package if you don't have it already. If I hover over the package, it looks like there's two commands that I need to include to use this package in my project. The find package command, which I already have, and then the target link libraries command. I actually already have target link libraries in this script, so I'm just going to add glog. You might also notice that this project is inheriting some default project options, default compile options, default linker options. If I didn't know what those options were, we've added language services to CMake scripts, so you can do things like peak definition, go to definition, and I can see exactly what those linker options are enumerated for me. You can see that this is pulling from a separate file and a separate subdirectory of the project. And this is really common when you have large CMake projects. Oftentimes they're structured across multiple CMake scripts and multiple subdirectories. So this is just a way to hopefully make it easier for you to make sense of and edit large CMake projects. Close that, check on this, and it looks like that's done. It's telling me I need to regenerate the CMake cache to detect the new package, which is why this gold bar appeared. So I will regenerate, and I'm good. If you take a look at my Solution Explorer over here, the layout of my files just is a mirror of the layout of my files on disk. And this is a pretty small project, so that's fine for now. But if you had a larger CMake project, then we have something called a CMake targets view, which is a more CMake-centric way of viewing your code organized by target, and it might be an easier way to navigate your file structure. We also recently added the ability to add, remove, rename files and targets in your CMake projects. So for example, let's say that I want to add a new item. I want to add a new source file. I'll just call it source.cpp. Instead of just dumping the file on disk, Visual Studio will try to help me incorporate that source file into my CMake project. So automatically adding the references to my CMake scripts. If there's any ambiguity, then Visual Studio will give you multiple guesses as to where that reference might be added. So if I wanted to keep this change, I could hit apply. Otherwise, I can hit cancel. And there's a million different ways that you can author CMake scripts, but this is our attempt to make it easier to do kind of common actions. So I'll cancel that. And while none of these CMake features I just showed are specific to WSL, they work on Windows, they work for WSL, or they work when targeting Windows, they work when targeting WSL, and they work when targeting a remote system. Because CMake is our recommendation for anything cross-platform, hopefully these CMake features will make it easier for you to target both Windows, WSL, or remote system at the same time with the same source code. That said, so far I have only been building and debugging on WSL, so I'm going to show you how quick it is to retarget the same project for Windows. So I'm back to the CMake settings editor, and I'm going to add a new configuration. So I will add a x64 debug configuration. I don't really need to change any of the default values here, but again, I could do things like configuration type, my compilers. If I had a CMake toolchain file or any CMake variables that I wanted to specify, I would do that all here, which is basically where you instruct Visual Studio how CMake and the underlying build system should be invoked. So it looks like CMake generation is done. I will make this new configuration active. And then I'll just go ahead and run the same executable to show you that it's the same program, this time running on Windows instead of on WSL. So I can read in expressions. I can evaluate expressions. Oh, my breakpoint still exists. Behave should, and I will. If I hop on over to the integrated, I'm using Ubuntu, but you can interact with PowerShell, CMD, or whatever WSL instance you have. I'm dropped right in my working directory, which in this case is my C drive. So this shows, oops, I'll move up 2 levels. So this shows that I'm using the same source files, the same CMake settings file, the same root CMake list to build my project debug on both Windows and on WSL. Now I cd into my output folder. You can see that I have 2 subdirectories, one for WSL that contains ELF binaries, and one for my Windows x64 configuration that contains the exes for Windows. So same source code, but 2 different binaries. Right now, I'm just using this integrated terminal to navigate my file structure, but you can use it however you might use to run your command line tools or to do whatever you might do normally from the context of Visual Studio. This is currently experimental, so I think you need to go to Tools Options in order to turn it on, but if you just search for integrated terminal, it's this integrated terminal requires restart item. All right, so another thing that we hear from C++ cross-platform developers is oftentimes they will only build locally for one of their target platforms, and then they'll rely on their CI systems to catch build errors across their other target platforms after checking in. So Visual Studio has a feature that will hopefully make it easier for you to catch build errors across multiple different platforms before checking in. So now that I have my Windows configuration active, let's say that I want to add something or I accidentally add something that is Windows specific, like Windows.h. Then, all right, then you see I get these purple squiggles, which is basically Visual Studio warning me and saying, hey, this is going to work for your active configuration, but it's not going to work for one of your other defined configurations. In this case, it's not going to work on WSL. If I were to toggle and make my WSL configuration active, then these squiggles turn red because Windows.h is just not defined on WSL. if I were to wrap this in an ifdef, so ifdef win32 and if, then you'll see all the squiggles go away and I'm back to having platform agnostic code. So hopefully this platform-specific IntelliSense will make it easier for you to catch build errors across multiple platforms that are defined in Visual Studio before you check in, even if you are primarily someone who develops for WSL, but then just has to also build, like also compile for Windows, or vice versa. You mostly develop for Windows, but you want to make sure that your code also compiles for Linux. And the last main feature that I want to show you guys today is something that we call the separation of build and debug. So this is basically the ability to separate the system that you are building on from the system that you are deploying to and debugging on. And these two systems don't necessarily have to have the same architecture and instruction set. So for example, you could cross-compile on a Linux x64 system for ARM, and then deploy that binary to a second remote system that is actually running ARM and debug on that second system using GDB server and a local copy of GDB. And that's actually a workflow that I recently published a blog post on to the C++ team blog. The example that we're going to walk through today is a little bit more streamlined. I'm going to be using my existing WSL configuration for build. So I'm going to be building natively on WSL, no SSH required, but I am going to add a new debug configuration. So if I go to my root CMake list and I select add new debug configuration, I want C++ launch for Linux GDB because I'm going to be debugging it on a second Linux system using GDB. So launch.vs.json is where you configure debugging sessions for CMake projects in Visual Studio. There's only a few tweaks that I need to make to this file. So first of all, I'm just going to specify a name so it's easier for me to identify this configuration. I'll call it my config. I need to specify a project target to invoke, which in this case is just my calculator exe. It just needs to match the name of whatever you're trying to debug from this drop-down list. And then the last thing I need to do is change the remote machine name. So by default, you will debug on the same system that you're building on. But if you want to separate those, then you can specify a new remote machine name. So I'm prompted with IntelliSense, which is just control space, with a list of all the remote systems that I have stored secured connections to. I'm going to be debugging on a Linux Docker container running locally that I'm connected to over SSH, which is this one. So I'll select that, save the file. Can you guys see this terminal? I think probably. You can see that the only running processes right now are the shell and SSH. But once I select this new debug configuration and launch the debugger, what's happening here, just to recap, is that I am building locally on WSL, so no SSH required there. And then I'm deploying the compiled binary to my Linux Docker container that I am connected to over SSH. And I'm going to start a debugging session using a copy of GDB that's installed on that Linux Docker container. So when this is done, I'll show you how all that's working. All right. So I can go back to my Linux console window, and from the user's perspective in Visual Studio, this looks exactly the same as we've been seeing over and over again. But if I were to bring up my Linux Docker container, now you can see that GDB is running. You can see that the executable I've deployed is running. You can also see here I'm in my output directory. You can see that only the binaries are being deployed. There's no intermediate build output that's being deployed. By default, it's just enough for you to run and debug the application. If you want to copy over additional files or directories, you can configure that in launch.vs.json. The link actually here that's in the schema contains information on how to do that, but By default, it's just enough for you to start debugging. So that is the separation of build and deploy, and that kind of wraps up the demo session. I'll go back to the slide deck now. A quick summary of what we talked about today. So I showed off some debugging features when you are debugging on WSL. Hopefully this showed you that you can both leverage the full fidelity Visual Studio debugging experience directly from Visual Studio when you're debugging on WSL. So things like navigating the call stack or setting breakpoints, or if you want to examine any variables, as well as us trying to bring native Linux debugging features into Visual Studio for when you're working with WSL. That's things like address sanitizer or the ability to execute custom GDB commands. We showed VC package integration for library acquisition, which can be used on both Windows and Linux systems. We showed off CMake specific features like language services and project editing, which will hopefully make it easier for you to make sense of, edit, and author your own CMake scripts for C++ cross-platform development. We showed off platform-specific IntelliSense to help you catch build errors across multiple platforms before checking in. And we ended with the separation of build and debug, or the ability to separate the system that you are building on from the system that you are deploying to and debugging on. One last thing that I want to note is that today all the demo was done in a CMake project, but this exact same suite of features, the debugging features, not CMake specific, I guess, but code navigation features and editing and debugging, all that is available with MS Build-based Linux projects as well, which can also be used to build and debug on WSL natively. So if you are only building for WSL, or if you really don't want to use CMake, then you can use MS Build-based Linux projects to build and debug on WSL from Visual Studio and have a very familiar Visual Studio experience. Today, I have been using WSL 1 for my demo. I was using Ubuntu, the rolling distro. You can use WSL 2. Everything is supported except using our native support, storing your source files in the Linux root file system. We are working on that actively, and the C++ team blog is going to be the place to go to get updates on that. And that's about all I had. The code base that I used today is all available on GitHub. I've commented in the code, the places where I showed you things in the demo today, so you can kind of play around with it yourself. C++ team blog is a great resource. Any new features or new workflows I'll often publish directly to there. And then this is some relevant documentation. I'm not sure if I can share these slides. Feel free to take screenshots of this slide right now. It's just some further documentation on our native WSL support, our CMake support, debugging CMake projects in Visual Studio, and then that's the documentation on VC package that I was talking about. So you can ping me and the team with questions. Please do feedback what you guys want to see. And hopefully these resources will help you kind of get started. That's pretty much all I had.
Very cool.
Yeah.
We had some questions if you have time.
Yeah, I can do some questions.
Let's see. Any plans to expose a targets view, like what CMake has for folks using CPP properties.json?
So I guess I'm not. Targets view in Visual Studio means the way to view your file structure that is organized by target, which is similar to what the CPP tools has. I don't know if that was referring to something else, or if that was before I got to that point in the demo. But CMake targets view to us right now is the thing I showed in the Solution Explorer.
Gotcha.
Yeah.
Okay. Any other questions on that, Josh? Follow up on Twitter. Are there any plans for this integration to provide a C-line-like interface to GDB within Visual Studio rather than just the shell?
I guess I'm not sure exactly. I'll have to.
Some of these are some pretty deep C++ questions that even I'm not familiar with.
Okay,
Sorry.
yeah. For as far as interacting with GDB, as far as what exactly C-Line supports today, I could like take a look and let you know where plans align or diverge, if anything. Um, but yeah, that's my answer for that one.
Yep. Tough. Yep. One more is, and I think you answered this. The Visual Studio Solution project file structure, is that still required for remote Linux projects?
No, it's not required. So if you're using our CMake support, then you can basically we never generate Visual Studio projects and solutions as like the file structure. If you're using MS Build as your underlying build system or your generator on Windows, then we do generate that for like, or we use that for IntelliSense and just because it's your build system, right? But if you're working on like our WSL or a remote system, then you might be using make files as your generator. And in that case, we're never generating any Visual Studio project and solution files at all.
Okay.
Yeah.
Okay. And one more question. How do
Yeah.
you cope with case-sensitive file names in projects?
Case sensitive file names and projects. So that's becoming more of an issue. Like we can handle it on our end. It is becoming more of an issue when if like I said, if you're storing files directly in the Linux root file system with as you can with WSL2 and it's recommended with WSL2. So opening those files that are stored in the Linux file system in Visual Studio is kind of what we're working on now to unblock that scenario.
We have a couple minutes left because we're waiting on Josh. Can you tell us a little bit about what happened with DICE at EA? You have a great blog post about it, but can you summarize it?
Oh yeah. So yeah, sure. So EA is using, they're not using our like native CMake support. They're kind of generating underlying like Visual Studio projects and solutions, but they are still using our WSL and Linux support. They have a pretty like their own kind of custom build step using Canadian cross compiler. So they hooked that up with our Visual Studio support and are basically using Visual Studio to build and debug and as an editor. So their workflow was really interesting, I thought. So we partnered with them to uh, document a blog post that kind of walks through their scenario and um, yeah, that walks through the scenario and how they're using our tooling, how you can get set up with it. There's actually a couple Oracle, like the MySQL Server team, is
Right.
also they're actually using our CMake support. And so just in general, if teams are using the support and have kind of interesting workflows that we think could be interesting to highlight for other people, I've been trying to cover that on the C++ team blog. So EA and MySQL Server are two examples of that.
Cool.
Yeah,
Thank you so much. And I'll post a link to that blog in the chat as well. Thank you,
awesome.
Erica. Thank you for
Yeah, thank
joining
you.
us.
All
And with that, I'm going to pass off hosting responsibilities to Sohini, and she'll
right.
be bringing Josh on board. Thank
Bye,
you, Erica.
everyone.
Bye.
Thanks.